So one paragraph when you read out start, obviously when you talk about the first wave of tools in the Stone Age, which gave us physical leverage, and then you talk about the second wave, which gave us the intellectual leverage through printing and up to computers now. And now this is the third wave of AI, which gives us decision-making leverage. And I was surprised when you said, actually AI started 70 years ago already, and it will actually only last until 2050. And you also make clear, but it's not only is this not too late to start with AI, but really you have to do it now. So why did it take 70 years? And essentially, how will AI now explode? Because it's everywhere.
Yeah, look, I think intelligence can take many forms. You know, if you think of intelligence, or you define intelligence as the rate at which you learn, which is how I define it, and in day-to-day life, and also in the book, it can take many forms. You can develop systems that learn lots of different ways, and so we have just experimented with lots of ways to do that, and there are lots of parts to it. You know, we as humans learn in so many different ways. We learn by seeing and processing sensory inputs. We learn by doing our own very basic calculations. We learn lots of different ways. And so, you know, we just had to experiment with which of those ways we could put onto a computer. And we did that by doing animal experiments, doing human experiments, developing circuits, like the substrate on which the neural nodes, I guess, can run. We had to sort of take statistical methods that we're already using and see if they could sort of provide us with some form of intelligence. Look, our own intelligence is very complex. And so we just had to experiment with which parts of it we can run in a discrete basis on computers. So there's a lot of experimenting to do. It's taken us a long time to do that. I just want to say one thing. I don't think the AI first century will end in, you know, a couple of decades. I think it will be the case that what we now call AI will just be part of everything. It'll be part of all our existing computer systems. It'll be part of our day-to-day life. It will be part of, you know, maybe even embodied in us, part of our own bodies. So it's the case that this is the AI first century, where people have to put AI first in order to get these systems to the point where, you know, we no longer think of it as artificial intelligence. We just think of it as another form of intelligence that we use all the time.
Yeah. So if we look to a lot of the, I mean, if you look at the web, if you look to events, if you look to talks, AI is a very strong and partly abused buzzword, I would say. And in the many, so as you know, we have a lot of manufacturers as customers, sorry, and essentially, while they talk about AI, honestly, there's little impact with them currently. And what are the drivers that change that now? Is this the competition that is rising, or what are the industry drivers that basically move us forward now? And why is it key to not miss out on AI if you want to be competitive?
So it's both, right? So the ability to use it means that people are starting to use it, means that it becomes a competitive imperative. And so, you know, what is the ability to use it? What has changed there? Well, you know, of course, more data, more models that you can actually work with. You know, they're not just theoretical and research papers. They are programmed or instantiated in computer code. Better computers that can actually run those models that require lots and lots of computation, lots of steps in computation. And finally, all the pieces in between to easily build, test, train, deploy, run, measure, and retrain machine learning systems. You know, all of these bits are there in that they're there to solve many problems, not every problem, but many problems. So, it's the case that we're at a point where a lot of these systems are usable. So a lot of people are using them. So if you're not using them, you might fall behind. Maybe not, but if they tend to be useful in your industry, then yeah, you will fall behind. So that's what's changed. It's just the usability of the system has gone from essentially 0 to 1. And if everyone else is using it, then you have to use it too. And that was really the imperative for writing the book, which is, spending a lot of time around companies that were pioneering the use of AI, and then realizing a lot of companies are just not, like spending a lot of time with bigger companies that are just not using AI. I realized that, look, there's this new form of competitive advantage that some companies are getting, and it compounds really quickly. And so if you don't get onto it now, then you're not going to be able to catch up later. You can't just sort of patch it on later. And that form of competitive advantage, I coalesced into this concept called a data learning effect.
Yeah. And so on a little side note here, what I read another book on AI with like on the angle on China versus Silicon Valley and the rest of the world, where basically there was a rise of papers around AI submitted by China rose from like 5% to almost 30% in 10 years. And they're investing also a lot more. How do you see that? How much of a driver is that? Does this mean anything for the US and Europe specifically now when they invest so much in that?
Yeah, I mean, look, I think it's a leading indicator. And the actual or even lagging indicators are very industry specific. So it's a leading indicator in that, this research can very quickly go into production these days. If someone develops a new theory of how a machine can learn, a new type of neural network, a new type of reinforcement learn system, publishes a paper around it, usually either in that paper or soon after, it can be instantiated into computer code and then run on a computer. Now, of course, there are lots of nuances in how those sorts of models go into production, so to speak, is in how they work with real data and not just test or experimental data, etc. So lots of nuances there, but it's the case that, because of all this infrastructure that exists around AI right now, with the ability to put neural networks in general into production. If a new type of neural network's developed, it can be put into production really quickly. So it's a leading indicator in that way. If these models are being developed, they might be able to be used very quickly. In terms of lagging indicators of the competitive imperative, it's certainly the case, and I'm sure a lot of your customers and a lot of people on this call realize every day that there are companies in other parts of the world that are getting an advantage very quickly in very specific ways. So they're able to produce something more cheaply because they have less downtime on their production line, because they've figured out the source of those errors and learned how to predict them better so that they can get ahead of them. So, obviously in lots of different industries, you use lots of different systems to reduce the cost of production, and that has an effect on everyone's bottom line.
So in the book, you describe nicely how our massive neural network that we have here in our skull with the membranes and the liquids and how they are connected to the muscles and the nerves, and allows us to write a logic code on paper, which we then run on computers, and now with AI, the next step. And the key term, and this is how you introduce actually the chapter like that, is about data learning effects, DLEs. So can you please explain that? I found this a very important cornerstone of your book, the 3 substrates, how they connect, how they compound.
Yep. So, I mean, the first thing to say is the idea of a data learning effect is a pretty big idea, and it's the big idea of the book, and I can't do it justice in a few minutes. That's why I wrote a book, right? That's why I didn't start a podcast or write a blog post. So it's in a book, and there are lots of illustrations and lots of equations and things that can help people understand it. So I'll try to do that now, but if you don't get it, it's very easy to just pick up the book and see it expressed in a different way, you know, visually or otherwise.
Yeah.
So a data learning effect is the automatic compounding of information. And so let's work backwards there. You know, data learning effect involves three things. One, a critical mass of data. Two, a capability to process data into information. And three, a system that can learn itself without any human input over that information. And so firstly, a critical mass of data. It's having enough data that in totality could perhaps provide some information. You know, sometimes you can tell a lot from a small data set. Sometimes you need a big data set. Now, data itself, though, doesn't really help you learn. You can't really learn from just looking at a bunch of ones and zeros. You've got to turn it into information. And so that's where the capability part of this comes in. You know, that is cleaning up data, adding context to data, labeling data, organizing data.
Yeah.
And then once you're tagging data, so then once you've got it into a system with all of that context, you can look at it at that point and go, maybe I can learn something from this. Maybe I can see a pattern here or something like that. Now, of course, we can look at that as humans and learn something from that, depending on how the information is represented. But the third part of data learning effects is where it gets really powerful. And this is where the automatic compounding part comes in the automatic compounding of information. And that is, you know, a machine learned system or a reinforcement learned system or some other intelligent system can take that information and effectively spot patterns. And then as more data comes in and is processed into information, it can spot more patterns and automatically correlate and learn more and more, and eventually generate its own data because it learns something, develops a prediction of what might be next, and that prediction plays out over time, and it figures out, oh, my prediction was either right or wrong, and then it corrects it and generates feedback data. And so that's what's really powerful here. And so that's what a data learning effect is. It's the automatic compounding of information. It involves three things: critical mass of data, capability to process data into information, and a self-learning system that can then generate its own data and go round and round.
Yeah. So when you talk about critical mass of data, and I think it's clear to anybody already that having proper data is the key fundamental underpinning of any AI strategy. And what's your recommendation to companies how they should deal with their data strategy if they want to go into AI, into AI use cases, let's say?
Yeah, look, good data practices always help. You know, in a sense, for years since we've been using any sort of information system or database, we have always, as business owners, business leaders, you know, just people working in business, been very concerned with making sure our database was in good order, because our database is our representation of the reality of our business as best we can represent it in a computable form. And so we've always sort of worked on organizing, arranging, cleaning, whatnot data into a database. But as you go into working with AI more, it becomes even more important to do that. And so, you know, good data practices, putting everything in one database, having one policy for dealing with certain data, having data stewardship, so having someone enforcing that policy, all help. And then from there, it's about figuring out what data you don't have that you need. And so that's a multifaceted consideration that I go into in the book.
Yeah. When I was really surprised, and also about the anecdotal details that you gave on the creativity and innovation that goes into collect, find, tag, and get access to data. And you show the many options that there are, internal, external, and how you can do that, and also the business models around that. And so it seems tagging is, of course, a very important requirement in order to benefit from the data that you collect. And when you have structured data, it's easier. When it's unstructured, it's difficult. When it's images, it's even more difficult. And so if I look to, let's say, a manufacturer that is listening in today and considers to really get into their first bigger AI project, what kind of data they should really look at? What has the smallest effort in your experience? You've seen so many use cases. What data should be focused on in this first AI projects, or can this not be generalized?
No, I mean, it's a good question. I think I can. I often hesitate to generalize, but I think I can generalize here, which is anything that people are already collecting. You know, the reality is on lots of production lines, people are already collecting data. They're making observations at the same time every day. They're doing a quality assurance check. They are, you know, clicking yes or no to let something go through to the next part of the production line. People are already collecting data on production lines. And it's just about refining and structuring that. So making sure that the data collection is regular, it is structured, it's a binary value, a yes, no, or, you know, categorical value. And then it's put somewhere, really, rather than, you know, maybe just left on a piece of paper or in someone's head. And so the best place to start is with what you're already doing, and then just figuring out how to put it in one database so that it's in context with everything else, so that it can be processed as quickly as it needs to be processed so that you can use it, and so that, you know, it's there in case you want to use it later to develop some other model.
Yeah. I mean, you know, in our business, when we try to sell a real-time data store like we offer, we are often confronted with an IT manager who just was educated that storing data is very expensive and you should minimize it and optimize it. And I think that's kind of a rethinking that has to happen, that it's not longer so expensive, and at the same time you can access it in real time. I think that's also something that is helping along that way here.
Yeah, exactly. Yeah, I think it is a reframing that a lot of people need to do, which is, you know, they need to sort of figure out, well, how much incremental cost will it be over what we're already doing? And often it's the case that it's not. And I think the mindset shift here is a lot about thinking of this not as an IT problem anymore, but thinking of it as a core business intelligence problem, which is, you know, if you just pick the right database and you pick the right data management systems up front, it's easy just to store everything. And that is, you know, in the past, it was very expensive to buy certain databases and buy certain tools, but it's not anymore, because in the past you had to buy 10 of them because there was no one tool that could just put everything in the one place. Now, you know, a lot of those problems that we used to have around data management have been abstracted away, either because it's just got way cheaper to store data, or because the technology to store and manage data has got better. So both things have happened. And so in the past, it's been a real pain to manage all of this, but it's got a lot easier. And so now our consideration can move to, well, what can we do with all of this data? Can we create a predictive model? Can we automate something? Can we do something else? And so I think that's, you know, what is really helpful to realize, that things have changed a lot.
Yeah. So when you, let's switch a bit topic to another very important part of your book, which is around AI strategy in a company and AI teams in a company. So if you decide to go forward, your key recommendation that I learned here was that you said you have to put your AI strategy first, and you implement it across the board. You embed AI team across the company, and not just in, let's say, this is the ivory tower of the innovation group and they do the funny stuff over there. So why is this so key for success in AI?
Yeah, so if you think about it, strategy is about developing competitive advantage, which is, what are we doing every day to create a business that is sustainable, profitable, etc. And
what not to do.
And exactly, strategy is what you don't do, as in anything that's not furthering that competitive advantage is not part of your strategy, or should not be part of a good strategy, is not part of a good strategy, I should say. So DLEs are a new type of competitive advantage, DLEs being data learning effects. And developing data learning effects requires making them core to your strategy. And that means making sure whenever you talk about strategy, you always talk about, well, how does this further a data learning effect? How does it improve it? How does it make it better? And those conversations happen in all the divisions of your company and around the sub strategies or the component strategies of all of those divisions. Your pricing strategy, your people strategy, your policy, government policy strategy, your product strategy. All of these strategies can, and if you want to develop a data learning effect, will have a AI part to them. What data should we collect by adding this, or can we collect by adding this feature? What person should we hire? What policy initiative should we be aware of, government policy initiatives around data protection? And how should we price this to maximize data collection? So there are lots of parts of strategy that involve a consideration of what data can we collect, how can we process it into information, and how can we learn from that using a machine that will further your DLE.
Yeah. So among the many practical advices that you give that are in this book, I thought it's very helpful to understand how you put together a team of AI people, and you have like defined 8 to 10 different roles, very specific what they do, what their background should be, and even eventually where you can find them, and also go into other industries to find them. I think that's very important. And you make a point that management of that team is very different than traditional management. And so what does a leader has to think about when he implements such a team, how to manage differently and what to pay attention when hiring them? And I know this is again a huge topic, but let's just pick some highlights of that.
Yeah, sure. Yeah, look, it is a big topic, but I think what we can sort of take as like a starting point to understand this topic is the concept of centralization and decentralization. And that is, it's important to strike the right balance between letting data scientists and machine learning people work in a team together with good tools, good computing power, sharing information, running experiments together, etc., so that they are super productive. So that's important, but it's also important that they're able to, work with the people out in the field so that they can learn from them what is really happening in this business and what is predictive of what. People that have worked on a production line for a really long time, they know what causes a failure. And so, a data scientist can sit in a room all day long and guess and try to look at the data to figure out what causes a failure. But they could also just go out there and ask or talk to people on the line, and they can tell them, and then they can code that into the model and move on to the next prediction problem. So this decentralization, centralization thing is really important. The other thing that's really important is to recognize how roles are changing. It's the case that managing data infrastructure is very different to managing just computing infrastructure. That doing data science is very different to just doing business intelligence or analytics. And that product management or data product management, to keep this consistent, is very different to product management, as in thinking about how you design products to collect the right data is very different to how you design products to optimize for conversion through a series of clicks. So there are all these different roles. Even UI and UX design is very different in an AI first company. So that's the second thing, recognizing how roles are different. And the third thing is recognizing what tools you need to equip people, picking the right database, picking the right collaboration tool, etc. So to summarize, the decentralization and centralization balance is the first thing. The second thing is how roles have changed. And the third thing is giving people the right tools.
And you were a bit more provocative in the book, as you said, you need a new management for these teams. Why?
Well, yeah, it's because they have different outputs. So in the book, I have lots of tables. Again, this is a big topic, and this is why I wrote a book, not a blog post. But there are lots of tables there that show, all right, so a software engineer works on a waterfall chart and has tickets and outputs code, and which are really features, manifest themselves as features of a product. But a data science person, works with experiments and outputs reports and has a discussion. So, they do very different things, and they have very different work products, and their work manifests itself in many different ways. And so they need to be managed differently, in terms of their performance and otherwise. And it's the same for machine learning engineers. They're different again. And that's the same. It's the same for infrastructure engineers and data infrastructure engineers. They're all very different. And so I lay out, what are these roles? How are they different? And how does management differ for all of them?
Yeah, I think that's a very, very crucial part of the book, because I've never seen it so structured in a few pages. I love that part. So as you know, we deal a lot with large manufacturers that have plants across the world, thousands of production lines eventually. And the data collection and also the analytics and the data science has to run in the cloud, but also on the edge. And the edge increases in its importance. So I'm paraphrasing one of Mark Andreessen's famous quote here now when I say edge eats the cloud. So how do you see the role of edge in AI?
Yeah, I mean, look, I think AI can absolutely work on the edge, and it'll work sort of in the same way as in, you can use the edge to collect data and then feed that into a model that's being trained and run on the cloud. Or you can use the edge in a completely different way, which is, sense something on the edge and actually actuate a decision, as in sense something, learn something, run a predictive model, and then, take an action, stop something, move something, etc. So, some forms of intelligence may be limited on the edge because they require, computation or power to run that computation that's not available on the edge. But some forms can be uniquely run on the edge because, the sensor is there and, needs to sense and then react really quickly. So I think it depends on the balance between perception, actuation, and processing. But, there's certainly a huge opportunity for AI to run on the edge. It's harder for sure. Like, these models are sometimes big, sometimes not, but sometimes big, and sometimes need, a bit of work to run on the edge, but it's certainly possible.
Yeah. Let's look to a practical example, and it obvious. I had to think about one of your portfolio companies where I had once the privilege through you to meet the founders, and that's Invenia. And fantastic guys, the two. And they use AI not only to save millions of tons of CO2, but also they build a very healthy business. So can you just, obviously without telling the secrets here, but can you tell us how AI and DLEs help them, and how do they make that work?
Yeah. So to just add a tiny bit of context, it's a pretty difficult company to explain, but really what they do when it comes down to it is they predict the demand and supply of power on a power grid 24 hours ahead of time, a day ahead. So that's what they do. Just add a tiny bit of context to what you said. So they use AI, from start to finish. They use AI to collect data, to go out there and find data sources. They use AI to process data, to clean it up. They have lots of little, essentially systems that grab a data set, figure out the anomalous bits, remove it, add bits of it, augment it. So they use AI to process data. They use AI, most importantly, this is the most powerful use of AI in the company, to model systems, model weather systems, extreme events, and most sort of productively and uniquely, model energy systems, the flow of power through a grid. Does it go here? Is it stored there? When something happens on, or it's used on this part of the grid, how does it move to the other part of the grid, from like a battery to a node, from the generator to the battery, etc. So they use it to model systems. Then they use it, again, probably either most importantly or second most importantly, to decide when to make a prediction about whether or not power will be used and in what quantum tomorrow. And if they're not confident about that prediction, they don't make it, because then they have to put money behind it and it's relied upon by the rest of the grid. And that's a little bit complicated, but that's essentially what they get paid for, is making correct predictions a day ahead.
Yeah.
And so they use AI to figure out when to make those predictions. And then they also finally use AI to figure out how much capital to put behind that prediction. How right are we? And therefore, how much capital do we want to put behind it? So they use AI across the board, collecting data, processing data, modeling systems, deciding when to make a prediction, and then allocating capital.
I think one other element why this is so cool is, and you touched this in the book, because if you think about it, all the incumbents, the huge power companies, you would think you have no chance to get against these guys, because they have all the data for decades probably, and they just don't use it. And it's a really good example. I think that with an entrepreneurial mindset here and using AI, you suddenly are eye to eye with these guys and you outpace them actually.
Yeah, it is. A lot of people were using very different systems before NVIDIA came along, but they have really changed it from start to finish.
Yeah. So we talked already a bit about the fundamental importance of data to create AI models, AI loops that compound and help getting value out of the data. And the data is often structured and unstructured, and it has to be tagged. It has to be fast, because that's a big point. And so picking the right databases is a crucial part of that. And so allow me a little bit in our favor here. How do you think that a scalable, cloud-native, real-time SQL database that we are, how does that play into AI strategies and supports users and customers, developers, from your point of view?
Yeah, look, I mean, moving fast means learning faster. Processing, acting, learning from your action. Was it right? Was it wrong? Is how you get smart, right? Again, the definition of intelligence in my mind is how quickly you learn. And you have to move fast to learn fast. So if you're not storing and acting on data, as in if you're not observing things, putting them into a database, learning from it, acting on it, then putting the lesson from your action back into the database to update the database quickly, then you can't learn fast. And so you also don't just need to be able to do that quickly, as in like the upload, download time, but you also need to get context quickly, because you can upload a new piece of data, but if it's not next to another piece of data, like if an image is not next to text, is not next to the geospatial data, like the location of the image, then you're lacking context. And so you can't actually make that decision. So you can't get that loop happening. So it's not just about upload, download speed. It's not just, it's also about having everything in the one place. And so that's where something like Crate comes in, because it's one of the first and really one of the only databases that allows you to put all of these types of data in the one place, which means you can run the decision-making models off one database, and you don't have these really complicated pipelines that break When they break, you stop learning.
Yeah. Couldn't have said it better.
I'm sure you could have. It's your creation.
Let's focus a little bit on practical advice for somebody who is listening, is leading a business unit or a company, thinking about the first AI use case. How is it? What's the best way to identify within your business where do you start, and where do you start creating it, and are there such low-hanging fruits where you can generally say, well, if you have this problem, look at it, and start there.
Yeah, so I really tried to address this in the book by providing a framework that's new called Lean AI. And what Lean AI is it's a series of questions you can ask to zero in on what predictions are going to be valuable, or what automations are going to save us a lot of money. Because it is hard to figure out where to start. There are lots of things you can think of that might be useful to predict or automate, but you don't know which ones are actually possible to predict or automate. And so what you want to do is ask the right questions to get down to that. And so what Lean AI is it's a series of questions that allows you to figure out what's the one database we can grab, the one model we can run over the data in that database, and the one report we can generate that will show if we're able to predict this thing. And we might find that we can only predict this thing to a 60% accuracy rate. But at least having done the experiment, we know that there might be another bit of data we can get, so we can spend money on getting that, or another model we can try, so we can hire someone to develop that model, or we can run the model over and over again and see if it gets better, so we can spend money on computation. But at least having narrowed down onto some experiment that you can run with one database, one model, and one report as the output, you know what to do next. And that's what Lean AI is all about. It's about trying one thing so that you can then do another thing, and so on and so forth. And eventually, the combination of, or the ensemble of models you develop and the lessons you learn, will probably represent a full-blown intelligent system.
Yeah. Okay. Yeah. Thanks. That was really a super insightful session, I think, and a teaser into the book. I recommend everybody to read it. Also, as a FYI, if you use the audiobook, which I did during hiking, it has a wonderful Australian accent.
Yes, I was very lucky to work with an actor that is not me, but he's much better than me at telling stories.
Yeah. So, thank you very much, Ash. We're at the end of our slot here. Thanks for taking the time. I recommend to everybody who listened in here, take a look at the book. If you have questions, just email me, Christian@Crate.io. And thank you, Ash.
You're most welcome. It's been a pleasure learning from you and taking those lessons and trying to present them here. And I hope they're useful to everyone.
They sure are. Thank you very much. Bye, Ash.
See you all. Thanks. See you, Christian.
Thank you. Bye-bye.
Bye.